Welcome to the 34826A BenchLink data logger software for the 34980A. This video demonstrates how easy it is to set up and conduct a data logging experiment without programming. In a matter of a few short minutes, you can have a data logging experiment up and running, collecting your valuable data. I'll step you through a power supply design verification application. We'll use the high-performance 34980A multifunction switch measure unit with the DMM, multiplexer, and general-purpose switch, along with the BenchLink data logger software. We'll measure voltage and temperature in a power supply enclosure to ensure the voltage output remains stable under different load conditions while maintaining minimal temperature rise in the product enclosure. The 34826A BenchLink software offers many features that allow you to get the most out of your 34980A. Use the 34980A for high-speed scanning up to 900 channels per second or high-density measurements up to 560 two-wire channels per mainframe. In 4 easy steps, you can connect to the instrument, identify your measurements, collect, and display your data real time. It is that simple, and you don't spend hours programming. Now, let's walk through the setup and execution of a simple data logging experiment for a power supply design verification application. To begin, we'll click on Add 34980As and select Find Instruments to search the GPIB, USB, and LAN interfaces. Once you've added your instrument, you can configure each channel for your desired measurement, including AC or DC voltage, 2 or 4 wire resistance, temperature, AC or DC current, frequency, or period measurements. As you can see, channels 1001 through 1005 are already configured for voltage measurements. Now we'll add a temperature measurement on channel 1006 with a J-type thermocouple. The Res column specifies the DC voltage measurement resolution or temperature scale for temperatures in degrees Celsius, Fahrenheit, or Kelvin. Scaling allows you to apply gain and offset to your measurement. For example, look at channel 1002. You will see a gain of 1.8 applied to that voltage channel. This is useful for custom linear conversions and to calibrate out losses, gains, and offsets. Here, you set an alarm to identify when your measurement is outside of expected limits. The voltage channels have high-low alarms set so that if the voltage goes below 11.9 or above 12.1 volts, an alarm is triggered. In this case, we'll set channel 1006 alarm to a high limit of 55 degrees. Under More, you can specify the system response to the alarm. You can stop the scan, beep, or log the alarm. Or in this case, we'll close channel 3101 to close a switch to turn the power supply fan on. The computer channels can be added for analysis purposes. The 34980A supports basic math functions, power equations, and strain equations. Now, let's set up the conditions for the scan. Specify whether the scan is to begin immediately, or you may specify a start time in the future. Since we need to prove the product design, we'll run the experiment for 24 hours with 5 seconds between scans. Once the scan begins, the system graphs your data in real time. The different channels are displayed in different colors for easy identification. Display options include data markers and alarm indicators. You may save your data or export it to another tool for analysis. To summarize, the 34826A BenchLink data logger software is a powerful tool for quick setup and execution of tests with the high-performance 34980A. Easily connect to the instrument, identify your measurements, collect and display your data in just a matter of minutes. And with the alarms, calculated channels, and scaling functions, you have even more flexibility in your data analysis.